Thank you, SQLBits, for giving me the opportunity to present today, and thank you, audience, for attending this session. I'm Shinduri. I'm a solutions architect with AWS, and I would like to talk to you today about big data on AWS through the lens of security. So, what are we going to cover today is I want to cover the background of why I chose this topic, and we want to discuss the big data posture and the security approach, bring them together and summarize on how to look at big data on AWS under the lens of security. Okay, the background. So as a solutions architect, I'm engaged with multiple customers from different countries, and these customers operate from different geolocations. And often they have staff which require access, and that access levels differs. And also there are questions about data protection most of the time. So one of the points of discussion when we talk about analytics and data is about the 80-20 rule. Where do you want to spend most of the time while managing security, data, and analytics? Today, I want to discuss some of the starting points to get going in the right direction. So I will start with the lessons from the field. And these lessons, there are many parts to it, but the key aspects, most frequently discussed topics when we are talking about data, analytics, and security is secure the access and data protection. So these are the most, why these two topics is, well, with the field experience, I see that these are the most frequently discussed topics from the customers, and they are the places where we can spend a lot of time, or we can do something about reducing the time spent on these two aspects while operating on AWS. So let's begin with the big data approach. Now, when we are talking about big data approach, what you see here is the data pipeline. From left to right, you see the data pipeline. You have systems which are generating the data. You have systems that are generating the data. You have systems which are collecting the data. You are designing systems which are storing the data that is collected. And then we progress towards ETL, which is extract, transform, load. And then we are in the process of analyzing and then build the visualization. So I would like to start my discussion when we are talking about accesses and data protection. I would like to start the discussion from the right end of the data pipeline. And why is this so? So it is always with the end user of the data, the end consumer of the data. And when we can work backwards from that point about who requires what type of access, it is easier to decide the access levels in the rest of the data pipeline. So once we know the right end of the pipeline, who is the end user of the data and what type of access do they require, what level of sensitivity of the data that you need to be giving access to, it is easier to come back to the beginning of the data pipeline, which is generating systems, generating the data. So at the start of the pipeline, you each may have various systems that are generating data for more than possibly what's there on this list, right? So we might have IoT devices, we might have many different types of sensors which are generating the data. So when we are looking at, this is not the comprehensive list of the generation of systems which are generating the data, but I would like to look at this as the two ends of making a sandwich, like just giving a very common example of how you want to look at the data pipeline. So you have the systems which are generating on one end, and you have the end user who is the consumer of the data, and all other elements that we are presenting in between are going to be the parts of the sandwich. I will come to the next system is collecting the data. So in AWS, if you're familiar with the different services under data collection systems, this is just a list which is not comprehensive. It's not listing all the collection services. But for our use case here, or for our discussion here, we are just talking about these services. So there are very different services like Kinesis Firehose, or you're talking about Kinesis Streams, or we are talking about database migration service, or any polling application. Now, you might ask, oh, where is IoT here? Isn't it a collection system? What about Snowmobile, which is going to transfer data from data centers to AWS data centers? So what about these collection systems? So we're not covering them here as such, but this is based on the use case or the discussion in terms of bringing analytics as a perspective. So when we are talking about the storage layer, we are starting to talk about storage as Amazon S3. This particular discussion, I have chose a NoSQL database, also RDS and database on EC2. When we are talking about RDS, it's a relational database service, a managed service where you can run various versions of SQL or Oracle or different database types such as Aurora. So DynamoDB is the NoSQL database. So in a big data analytics use case, we can see these different types of storage systems. So what do we have for ETL? While we see the first layer of ETL, the first service that we are looking at here is Glue. Glue is a managed service, serverless ETL service, in the sense the customers need not provision servers in order to build the ETL pipeline. So it's a fully serverless ETL service. I put Lambda here. So any of you who is familiar with Lambda, which here talking about compute without, again, serverless compute, you might want the, within a fraction of a second, without provisioning a server, you want to transform the data, right? As simple as dropping as simple as dropping an object into S3 can trigger the Lambda to process. So we are building event-driven processing system with Lambda. And then we are talking about Amazon Kinesis enabled. That means you are using the client libraries of Kinesis to build applications on EC2. So when we are talking about extract, transform, and load, this is not the comprehensive list. There are many ways to achieve it, but these are the most used services, so we are going to talk about this. Then we talk about the analyze phase, where in the data pipeline we are looking at EMR, which is Elastic MapReduce. Elastic MapReduce will let you provision Hadoop clusters or your big data processing systems. Either you're using Spark or Thais or Hadoop clusters within a matter of few clicks. And we are talking about analysis using Redshift. Redshift is a petabyte scale data warehouse. And then Athena is an interactive service which will let you use native SQL tools with the data that is stored in S3. Then we have Kinesis Analysis, which will let you query and analyze the data while it is in the stream. So while you can see the entire set of tools, like the list of tools for the different stages in the data pipeline, let's focus on the elements here and choose one of this pipeline for today's discussion. So this is the pipeline that we are going to talk today. And with that, I will introduce you to the security approach. And so how do we look at security approach on AWS? Now, when we talk about the security approach in AWS, many customers start the discussion with, how do I start with security? And my favorite place to refer the customers is the Cloud Adoption Framework. So when you look at the Cloud Adoption Framework as a reference, there are many epics and topics within the Cloud Adoption Framework which will give the customers the right framework to design and enable end-to-end security while operating on AWS. Now, while we discussed about the two different extremes on the data pipeline, which is starting with the systems which are generating the data, and then there are systems which are the end users who are consuming the data. Between these, we are building the elements, which we saw on the services. Now, think of security as the magic sauce. So it is not the garnish that we are going to put at the end of the, while your burger is ready, but it is the sauce that makes the entire burger really come out as a wow factor, right? So security has to be an element which can be thought through as an end-to-end, not something that we think about it at a later stage. So while we are focusing our discussion today on identity and data protection, that's what we discussed in the beginning of the session, is that these are the two main elements of discussion for today. So how do we bring these two into coexistence? We saw the big data approach, we saw the security posture. Now let's bring these two together. So I'm going to simplify the story, and we are going to talk about the two objectives within the elements of the big data pipeline. And when we talk about secure access, these are the three elements that we need to think about. Who or what can provision the service within AWS? And the second is who or what can interact with the service, and what should the service be able to do for you, based on which you can decide the access levels required for achieving the access objective. So this is the data pipeline that we are considering for the discussion. So let's see for each of these service how we are talking about access and data protection for each of these service. Starting with Kinesis Firehose. Amazon Kinesis was an ingredient in the collect phase of our data pipeline. And if you look at the access for Kinesis Firehose, we always start with access in AWS by talking about identity and access management. Identity and access management allows you to give granular, fine-grained granular access, and it can be given to the user, or it can be role-based, or it can be given to an application. So it lets you set the permissions at a very granular level. I will walk you through this very simple example. So you might ask, how do I get started? It all seems like, OK, where do I get started? How do I start setting up this access? Before we go into how to do that, I would ask you to go back to the three questions that we considered. Who or what can provision the service, and what that service is going to do for you, and what that service is interacting with. Who or what is the service interacting with? So these three will help you write the policies or select the policies that you want. To get you started quickly, we have AWS managed policies, which will help you with the set permissions rules already available for you. And these can be customized to suit your business case, suit your individual unique business case. What about the data, which is data protection? So we discussed about the access. Now what about data protection when the data is being consumed by Kinesis Firehose? So we have server-side encryption with Kinesis Firehose, and you can achieve the server-side encryption with KMS. If you have sensitive data, you can enable server-side encryption with Amazon Kinesis. And however, this is possible if you are doing it when you're setting up. So we will see how to do that while you're starting the service. So if you see on the left-hand side of the screenshot there, you have the steps to set up the Kinesis Firehose. Taking you back one step is, what is Kinesis Firehose helping us do is collect the data. Now, you have to select Kinesis Firehose as a data collection system. That means you have to define what is the source of the data generation. And you're setting up Kinesis Firehose to collect the data. And since there's a source and you are using the Firehose as a collection system, you have to define the target for that particular data. While you're setting it up in Kinesis Firehose, you can see that you can enable the access, and you're giving permission for Kinesis Firehose to store the data in S3 which could be your target for storage. And you are enabling security there, and hence, end-to-end in the collection phase, you are securing the end-to-end pipeline while using Kinesis Firehose. So server-side encryption enabled for S3. That means you are using the target server-side encryption to protect the data. So let's look at the next element, which is storage. So we have done with collection, and we have seen how to secure the data while the data is in collection phase. Now the data is stored in S3. S3 is simple object storage, and it is unlimited storage, and it provides 11 nines of durability. So how do I secure data while it is being stored in S3? First is the access. Two parts to it, again, access and data protection. The first is access. So whenever we talk about access control in AWS, we start with IAM, Identity and Access Management. And Identity and Access Management, you can define it based on the user, who is a user, and what permissions would they require, and the resource policies. Or you can even use conditions. For example, you want a particular user to have access to a data point, but you don't want them to have any write access to the data. So you can have those conditions built into the policies, or you can have policies at the bucket level or where you're storing the data, and you can control the access even through access control lists, which can help you define fine-grained access overall while the data is in storage. Who accesses the data in what form? Now, when we talk about creating the policy, it's the same. You can get started very quickly without thinking about how to write the policy by using the AWS managed policy and customize on top of it. So taking you back again to the 80-20 rule, where do you want to spend most of the time while you're thinking about data pipeline and security together on AWS? Start with the managed policies, and you can easily customize them as you know your use case better. Now, what about data protection in S3? So while we talk about the data protection in S3, so S3 allows you to use the default encryption, which is AES 256 standard, and the entire encryption decryption is offloaded to S3, and it is transparently done by S3. If customers want to use KMS, KMS is Key Management Service, which will allow you to do server-side encryption again with KMS. Or the customers can use server-side encryption with custom keys. For example, you do not want to use KMS, and you already have a setup of key management system you want to continue to use. You can use custom keys to do the same server-side encryption. Within S3, you can also use client-side encryption if you want to do it from the client side, and you can continue to use KMS, or you can use client-side encryption with custom keys. So this is a screenshot of this what can be done over the console, AWS Management Console. What we are seeing here is either enabling the first option is no encryption. The second option is you're using AWS default encryption for S3, which is server-side encryption with S3, or you can use KMS. You can specify the custom key as required. So coming to Glue. OK, so I think we have established the pattern on when we are talking about access control to the data pipeline in AWS, it all starts with IAM. And we can define the permissions through user, role, or through application. Again, start with the managed policy and customize it as per the requirement. How do you protect the data while it is in Glue? So Glue uses SSL. So for server-side encryption, and when the data is in transit, you are using SSL. So if you select this option, when the ETL job writes to Amazon S3, the data is encrypted at rest using SSE server-side encryption for S3, and you're offloading that entire encryption. The thinking about how my data is protected, that is being offloaded completely. Okay, so coming to the next part is the analyze phase, where you have EMR. Now, with EMR, we are provisioning, again, you already know, we are starting with access control to EMR. How do you provide access control? With it gets a little interesting with EMR because you are talking about big data analytics on Hadoop, and you might be running different type of applications, and you might want to give access through LDAP servers, right? So that is, if you're running different type of applications, you can enable LDAP server access through LDAP, or you can log into the Hadoop cluster using SSH. So with the SSH user, the SSH user can log in, use the key pair to log into the Hadoop server, and being able to start the steps that you want to do in processing. And as a Hadoop user, so when you are doing SSH, you are actually logging in as a Hadoop user. And you can even, if you don't want anybody to log in using SSH, so here is where you want to decide what kind of access you want to give, right? If you don't want your staff to log in using key pair, then you're looking at how you can run the steps, the processing steps, using AWS credentials. Then you can go do that using the EMR steps using AWS Management Console or EMR API. So we can enable access also through Kerberos. So if you have Active Directory set up and you want to use key data center to actually run the access controls, and AWS enables that as well for the users. So what you're seeing on this image is that the user is logging in themselves, and then yarn impersonification can be achieved for the Hadoop cluster. EMR also has EMR FS, which is going to be EMR storage, which is using S3 as file storage. So with S3 file storage, you can use fine-grained access using IAM role and IAM users or groups. How you can enable this? For the Kerberos authentication, you can have the cross-realm authentication, and you can set up the ticket time. Like you set up in your current environment, we'll have to define the ticket time, and the setup can be done. And for authorization part to S3, right? When you're using EMR FS, you can set up the groups, and you can define the roles for that particular authorization. So with EMR in transit, when we are talking about data in transit, we are talking all these systems. If you see what is the slide talking about is how it is in end-to-end within EMR in the analysis phase. You are encrypting data in transit, and the data is encrypted in EBS as well as instant store, as well as while the data is stored in S3 after the analysis is complete, and you're storing the output in S3, or you're using EMR FS as the storage. So we are talking here about the local disk encryption. So here we are talking about how we are setting it up while your target is whether it is S3, while the data is in transit, or while you're storing the data in EMR FS. So that kind of brings us to the Redshift when in the analysis phase. So while you're using Redshift, again, the access control can be achieved through IAM, whether it's user, role, or application. You start with the managed policies and work with custom policies, customize it according to your use case. And when you're setting up the data protection, you can set up encryption at the cluster level, and the data in transit is protected by SSL connection, and we also have load data encryption. So what you're talking about load data encryption is you can either use server-side encryption. So while you're loading the data, whether it's from S3 or unloading the data to S3 from Redshift, you are still using server-side encryption. Again, server-side encryption can be with KMS or custom keys. And how do we achieve it? We are setting it up through the Redshift AWS Management Console. So to summarize, we are adding security as an ingredient while we are preparing the big data pipeline from end to end, and not thinking about security at the end while the data pipeline is already configured, or you have decided what are the ingredients in the data pipeline. So from collect to analyze, we are talking about integrating security throughout the end-to-end data pipeline. So where do we get started is the cloud adoption framework and the security epic with the cloud adoption framework. So as I said, start with security when we are talking about identity and access management, and we did not cover detection and infrastructure security and incident response in this talk. However, we talked more about identity and access management and data protection for the big data pipeline. So for other topics, there are other services, and we can cover, you can reach out to me if you have any questions during the session or after this session. Let's have some Q&A if you have any questions. Sorry. OK. It's either everything understood or nothing understood. Sorry. OK. OK, so no questions. OK, I would really appreciate your feedback, and look forward to talking to you again. Thank you so much. Oh, I'll leave that slide open. Thank you. Thank you.